This is the Algebra 2 Unit 1 Lesson 4 video. This lesson is all about solving linear equations and inequalities. This is intended to be a review of a big part of what you learn in Algebra 1. So I'm going to approach this as if it's a review. And what I mean by that is I'm not going to get into the details of how you solve equations. That's something that you really should know going into Algebra 2. We shouldn't be covering that as a new concept. So that's why this is kind of packed into one lesson. I mean, this is something that would be covered over the course of at least an entire unit, if not a unit or two in the Algebra 1 course. So what we're doing here is we're just refreshing how to solve equations that have one variable and inequalities that have one variable. So we're just doing basic algebra processes. So I'm gonna get over to our drawing here, and I'm gonna make up a couple of example problems for us. So again, we're solving for x. That's really all that this lesson is all about. So let's say I had 3x minus 2 equals 5x plus 6. So real quick, just to kind of recap, remember that when we solve an equation, we imagine that it is kind of divided in by this equal sign. And I'm just going to actually make that look a little nicer. It's pretty ugly. We imagine that there's a division of this problem there. And anything I do to one side of the equation, I have to do the other side, because the equal sign, if you remember, tells us that these two things are equal. 3x minus 2 is equal to 5x plus 6. So if I want to do anything, I have to do it to both sides so that the equation remains what we call balanced. So, but with our goal in mind, remember, we want to eventually say what x equals. And so the general goal, of course, is going to be to get all the x's over here on this side, and to get all the numbers over here on this side. And we're going to just basically reorganize the equation so that it does that. So if I was going to set out to do that, I could start one of two places. I can either move the 2 over with the 6, or I can move the 5 over here with the 3. So we're going to start with x's. So I'm going to start there. I'm going to move this 5 over here with this 3. When I say move it, I mean I want to do whatever I need to do to get rid of it on the side of the equation it currently is located. And since it is 5x, I'm going to subtract 5x from that side. And again, if I do something to one side of my equal sign, I have to do it to the other. So I'm going to subtract 5x from both. That is going to cancel this out, leaving me with 3 minus 5 is negative 2x minus 2 equals 6. All right, so now we have this equation. Again, the equation remains balanced because I did the same thing to both sides right there. So I'm going to do a similar process. I want to move this negative 2 or minus 2 with the 6. So I do the opposite. I'm going to add, I'll move this down out of our way here. Oops. Yes, move this down. I'm going to add 2 to both sides of the equation. That's going to cancel. That's what I wanted to happen, leaving me with negative 2x equals 8. Now we're getting closer. All my x's are over here. All my numbers are over here. The only problem is this negative 2 is connected to that x right now. So what do I do to get rid of that? Well, let's move this down further, sorry. I need to do the opposite. This is negative 2 times x. So I'm going to divide by negative 2 on both sides. Those are going to cancel, leaving me with x. 8 divided by negative 2 is negative 4. Use your calculator if you need to. And so this is the solution to the equation you see up here. 3x minus 2 equals 5x plus 6. In that equation, x equals negative 4. In other words, if I took negative 4 and I plugged it in for x here and here, then I would get answers that were equal to each other. So that's basically what you're doing here. So that's one example. I'm going to do a couple of more examples just to kind of make sure I cover all the material they have in here. Let's just make up another one. Let's say we have 4x. I'm sorry, I wanted to change colors there. 4x plus 3 equals negative 3x minus 11. Okay, so this is our equation. We have x's on one side and y's on the other, and we want to move things around, or sorry, not y's, numbers on the other. We want to move them around so that they are organized. X's on one side, numbers on the other. So we'll start with this 3x. I'm going to add 3x to both sides. That's going to cancel that out, leaving me with 4x plus 3x is 7x plus 3 equals negative 11. Notice that negative sign stayed with the 11. Again, I need to keep the equation balanced, so I'm going to minus 3 on both sides to get that 3 over here with the 11. That's going to cancel, leaving me with 7x equals negative 14. Again, use your calculator on these little calculations if you're not sure. I have 7x equals negative 14. Come through, divide by 7 because that's the opposite of what's happening. Right now it's 7 times x. If I divide by 7, that's going to cancel out, leaving me with x equals negative 2. And that is the end of that problem. So that's how you're going to do these equations. So a lot of this process is going to be the same for each problem. I do want to talk about 2 special cases that you might come across. For instance, there are times, I'm going to jump over here, where you will simplify your equation. I'm going to just highlight this example right here, where the x's get completely canceled out. If that happens, then you need to continue working the problem out until you get down to just 2 numbers. Okay? So that is going to be an example of one where there is no solution, because you can see, like in this example, the final answer says 12 equals 0. Well, 12 doesn't equal 0, which should be obvious. And so when that happens, this is an example of no solution. There is no solution to that equation. Similarly, if you solve the equation and you are left with only x's and no numbers, you'll see like they have here, and we get this final answer of x equals x right here, that means there are infinite solutions, or in other words, any number will work. Infinite solutions. So keep that in mind as you work through these problems. You might come across those 2 special cases. I will make sure to put something in the notes about that fact. So scroll down here. So that gets us through most of these problems, and then they introduce inequalities. The only difference between solving an inequality and an equation is that you have a different symbol in the equation. And there is one important thing you have to keep in mind. So let's jump over here and let's do an example of an inequality. Let's say I have x plus 3 equals 3x plus 10. Actually, let me do that. Let me do 12. Nope, 11. Sorry, guys. 15. So this might be my equation, and I already messed up again. I said I was going to do inequality. This we're going to make an inequality symbol. So this says, kind of to restart, x plus 3 is less than 3x plus 15. Now the process for solving this is the same as what we've been doing. So we're just going to jump right into that. I'm going to subtract 3x from both sides. X minus 3x. This might be a little confusing, but remember this is a 1. There's an imaginary 1 in front of that x, so this is 1 minus 3. That's negative 2x plus 3. Then I need to subtract the 3. Negative 2x is less than 12. Okay, now I said earlier that the way you work these out is exactly the same, and it is, except one unique situation that you need to keep your eye out for, and we have one right here. So I'm going to write it down next to this. So give me a second to write this down. If you divide by a negative, you must switch the inequality. What I mean by that is, if I'm working this problem out and I get to this step and I see, oh, I need to divide by negative 2. When that happens, this symbol right here needs to be changed to go the opposite direction. That's what I mean by this. You need to switch the inequality symbol. This still cancels out. X is greater than negative 6. So everything else about the process is the same. You still solve using the same methods, but if you get to this step and you divide by a negative, you must switch the inequality sign. So that's the only real unique thing you need to know about inequalities. You're going to work them out the same exact way. So you've got a lot of sample problems here. If you have specific questions about solutions, you can just reach out to me and we can set up a one-on-one time. But hopefully this will kind of get you started.